Today's webinar is Regression Analysis in FCS Express 5. What we're going to cover today is working with scatter with regression plots in FCS Express 5. And scatter with regression plots are new tools or new plot types to help display any data files or custom data that have the ability to update regression lines, models, and statistics in real time. For today's agenda, we're going to be covering how to insert a scatter with regression plot, how to work with that plot, format it, and change it to look just the way that you want. We're going to learn how to derive statistics and work with regression models. We're going to work with FCS files and regression plots directly. We're also going to go over working with custom data in regression plots, as well as using custom tokens in conjunction with model statistics from your scatter with regression plots. And finally, we're going to touch on working with regression plots for plate-based data. So again, scatter with regression plots in FCS Express can be located in the Insert tab 2D Plots section here. You notice that this is our scatter with regression plot. And one of the beautiful things about working with scatter with regression plots is they work just like any other plot in FCS Express. You can see that we've inserted one of these scatter with regression plots on this main page. And as you make any changes to gates or data, your scatter with regression plot is going to reflect those changes in real time. So you see here as I move this gate around, our scatter with regression plot is updating, as well as all of the fit statistics for that particular model. So here we have a linear regression displayed and a Michaelis-Menten regression displayed on this plot. And again, as I move these gates around, our fit statistics are going to be updating in real time. So as I mentioned, scatter with regression plots can be used to plot any data files. This works with FCS files directly. So if you have any sort of bead-based data where you're looking at a correlation of fluorescent beads or sizing beads, you can insert that FCS file directly and have that plotted in a scatter with regression plot, or we can work with custom data. So just like you would work with any sort of data in Microsoft Excel, we can essentially create a data table with columns and rows for any specific data points that you'd like to analyze in a scatter with regression plot, and we can plot that in there for you. Now also in FCS Express version 5, we can work with CSV files directly. So instead of working with FCS files, if you have any sort of data in a CSV type format, you can bring that in and work with that data in FCS Express 5 in the scatter with regression plots. So again, with our agenda today, we're going to be showing you essentially 3 examples in this webinar. The first one that I'm going to start with is working with FCS files directly. And we're going to look at some bead-based data to analyze that in the scatter regression plot. So first I'm going to insert a density plot so we can take a look at what this data looks like. And you can see here I have 3 files for analysis. I'm going to open the first, and I'm going to switch to our FL1 versus FL2 parameters. And you can see here that we have some fluorescent bead data, that there's 1, 2, 3, 4, 5, and possibly a negative population of beads in this particular data file. And we also have 3 data files associated with this data set. And you can see that they were loaded into our data list. As we click Next and Previous, we can see how that data looks. Now, if you'd like to insert a scatter or regression plot for any of your FCS files, it's very simple. Just like we inserted this density plot, we can come up to the Insert tab, choose Scatter with Regression. We can draw that plot on the page, and we're just going to choose that data file again here, and we're going to insert the scatter or regression for that particular plot or that data file. Now you can see that when I insert the scatter with regression plot, the first 2 parameters that we default to are the side and forward scatter parameters. Just like using any other FCS files, we can quickly change here to our FL1 versus FL2 to reflect what we've done in the density plot. And you can see that we've automatically created this red line on the data. And as we change data files, you notice that this line is updating for us. That's our regression model for this particular data set. So inserting these scatter regression plots is very easy. You just click on the insert button, insert scatter regression, and we're automatically going to try and determine a best fit for this data. Now, the other thing we can do with these scatter regression plots when working with FCS files is that we can create a gate on our data, and we will call this the bead gate. And we can apply these gates directly to a scatter with a regression plot. So if we know with this particular scatter with regression we're not really interested in this negative population, we can apply the bead gate directly to the plot, and you can see that that's going to update our regression line and the data immediately. And as we update this gate, you can see that our regression is going to be updating for us depending on where that data falls within the analysis. So again, this makes it really easy to work with the populations that you're interested in, especially if you're working with any sort of bead-based data. So how do we format this scatter with regression plot? Well, this scatter with regression plot is going to work just like any other plot in FCS Express 5. You can double-click on the scatter with regression plot, and you're going to be prompted with the formatting window. And we now have a category for regression fit, and this is where you can get any of the information about this fit model, including any of the fit statistics. You can see here that we have a linear fit defined. We have the M, B, and R squared values for that. We also have the number of regression dots that are being displayed on this plot. We're going to come back to exactly what that means. Now, by default in FCS Express, we're going to use a linear regression fit for your plot. If you'd like to change the regression fit at any time, you click on the regression type drop-down, change to whatever fit type you want, maybe this 4PL fit, and we click preview. You can see that our regression model has updated on the plot. Now, also our statistics for that model have been updated in our regression type statistics here as well. Now, in our regression model list, it's showing that we're using this 4-parameter logistic fit, but if we wanted to add another fit to compare multiple fits for the same data or use multiple fits for the same data, we can click the Add button, and you notice that a linear fit will be added. We click Preview, and you can see that our linear fit is now overlaid as a blue line on this particular data set. And we're also calculating all of those results. So this is a quick and easy way to compare as many different fits as you'd like. So if we wanted to add another one in here, we can click Preview, and you notice that we're actually going to have a few lines being displayed on a particular data set. And at any time, if you'd like to remove any of these, you just click the Remove button. We'll do another preview, and you can see that we're back to our linear fit for our data. Now, the statistics that are being displayed here are the statistics that are being calculated for the slope and the intercept and the R-squared for this particular data set. And at any time, if you wanted to use a fixed value, say we wanted to fix the intercept, instead of going through about 0.9 or 1, if we wanted to fix that through 0, we can just enter a value there. We can click Preview and watch what's going to happen to our line. You can see that it's actually being set to go through 0 at this point, rather than using the calculated value. And if you wanted to remove that, of course, we can just delete that number, click Preview, and it's going to go back to the way that it was. So again, anytime you want to use a fixed parameter for any of your regression models, you can certainly do that, and that includes sending the line through 0 if you'd like. Now, along with the regression fit category, you'll notice that if we come into the overlays category, all of the formatting options for overlays here for our linear fit are listed. If we wanted to, say, come in and change the connecting lines for that particular fit, sometimes you may want to make these larger. We can do that so it's a little bit bolder, and then you can also come in and change anything about the colors or the shape of this line as well. So these are more visual things about changing how that line actually looks on your layout, but what you should keep in mind is that you have full control over this, just like you would have in Microsoft Excel. Now, along with our regression fit model options here, just kind of coming into the formatting one more time, the number of regression dots is how many dots are being used to actually create this line. And if we wanted to maybe make this line a little bit smoother, you may want to enter a number like 100. In this case, it's not going to make very much difference. But if we went the other direction and we said change this to 5, you can see that we're actually using 5 points for this line. There's a point where it begins, a second inflection point, third, and then the other 2 points are in the linear range. They're kind of hard to tell where those are. So again, you can always come in here and change essentially the smoothness of this line if you'd like. So again, working with this data is very quick and easy, and we have all these statistics here for you. The other thing I wanted to show you is how we can actually insert some of these statistics on our layout. So with this particular bead-based data set, maybe we're interested in getting the R-squared value of this line to see how well it actually fits the data and how linear this data actually is. So just like any other statistic in FCS Express, you can insert a text box, and in that text box you can enter any kind of value that you want, but you can always right-click on this text box and choose Insert Token. And that's how you're going to come in and be able to choose any sort of statistic token. But an easier way to do that is to simply just drag this whole plot into the text box, choose Statistic Token, and then we're going to be prompted to choose a statistic associated with the plot. Now in our Select Statistics dropdown, we now have an option for Regression Parameter statistics. And when we do this, you can see that we have the ability to access any of the regression statistics that are associated with this data set. So this one particular data set, we'll just enter in the R-squared value, and we'll see that value is 0.98. And as, again, we update our gate and change this around, we can see how that fit or that R-squared value is going to change. So this is useful for a lot of things. We can see that right here, we'll just type in R-squared, and we'll remove this. We'll stick this right on the plot there by dragging and dropping, and we can see that this is a very good linear correlation. We have a 0.99 fit, whereas opposed to if we grabbed this negative population, we're still doing pretty well, but we can quickly kind of review where the best linearity of this data is just by using that R-squared value. So again, very quick and easy to insert these plots, derive statistics from them, and get the information that you need. And again, with this data set, we actually have 3 different data files, and if we wanted to look through the different data files, we simply choose Next and Previous, and the data is going to change on the plots, and our regression statistics are going to update in real time. So if you have a lot of data that you'd like to analyze very quickly, you can just load it up into the data list, and at that point you can simply run through all of your data files with a batch process. If you'd like to learn more about the batch process, please see our website, www.denovosoftware.com, and we have a recorded webinar on batch processing that you'll be able to access. So that goes over working with FCS files and scatter with regression plots. You're just going to insert these like any other FCS file, insert a scatter with regression plot, and work from there. Now, the next thing I wanted to go over is working with titration base data with custom tokens. So what we're going to do is actually use a combination of what we call custom tokens and custom data in FCS Express 5 to work with some data values. So let's bring up a new layout, and I'll show you a little bit about this data that we're going to be working with, and we're going to discuss working with data within custom data tables. Now we have a data set where we want to look at a CD64 titration and generate some sort of regression analysis on that data to determine the binding, the maximum binding for a CD64 antibody. On this first page, we're just looking at some gating strategies that we set up for sizing of these cells, and then also looking at specific lymphocyte and monocyte populations. Now on our second page, you notice that we have quite a few data files here. I'm going to open up my data list so we can look at these. And you can see that there's actually a titration series from 7 different samples, going from 0.156 microliters all the way up to 10 microliters of CD64 antibody added that's being measured in the FL8 parameter here. We also have our forward scatter versus side scatter plot here, and all of these you can see here the gate is applied to everything, and these are updating. So what we'd like to do for this data is generate a scatter plot or a regression analysis looking at each of the values in this titration series plotted against the mean fluorescent intensity of the FL8 or CD64 parameter. And what we're going to do is generate a curve to determine where the maximum binding of CD64 happens in our titration series. And what this is going to allow us to do is later on, when we work with some custom tokens, is back calculate the optimum amount of antibody to use based on this titration series of data. So to do so, what we need to do is create a table where we're looking at concentration versus the mean fluorescent intensity of each of these graphs. And to do so, we're going to actually create a new what we call custom data. This is located in the Data tab in the Save Load section in Custom Data. You can choose New Custom Data, and we will call this CD64 Titration. And in this particular data set, we will have 2 columns, one for concentration and one for mean fluorescent intensity, and then we'll have 7 rows for all 7 of our titration base data files. We'll click OK. You notice that we've created this table or this custom data table within FCS Express. Now these work just like any table in Excel. You can enter any sort of number into these columns here. You can do anything that you really want with that. And what I'm going to show you how to do is build these tables so we can plot the data that we put into this table in a scatter with regression plot. So we're actually going to have a little cooking channel moment here. I have already created a custom data table that has some values inserted, and you can see that here. So we're just going to delete this one that I showed you how to insert and begin working with this data table now. Now with this custom data table, you notice that parameters, I have these labeled as column A and column B by default. Anytime you can just right-click on this custom data table, and we can say, let's rename the selected column, and we'll actually call this concentration. And the second one here for column B, I'm going to right-click on it, say rename selected column, and this is going to be CD64 MFI. All right. Now these values are being derived directly from our plots. Instead of manually typing this concentration value, what I can tell you about these data files is that if I look at the header for these and I look at all of my keywords, one of the last keywords in the list is the concentration associated with that data file. So this is great. It means that we don't actually have to type in that concentration value manually. And if we had a series of different data sets with different titration concentrations, they would be loaded automatically. So let's take a look at how we can fill out this concentration table. We will look at 2 pages vertically. That way we have access to our values here, or our plots. And if I wanted to use the 5 microliter concentration from this plot, I simply drag it into the table. I choose keyword token, and I'm going to insert the keyword for concentration. And I happen to know that that keyword is CONC, and you can see that that value was now added to our plot, and it's being derived directly from the data file. So again, we can do that very quickly and easily for our 10 microliter concentration. We'll put that in there. And then we also want to fill out the CD64 FL8 mean fluorescent intensity. So again, all I'm going to do is drag this plot in here. I'm going to use a statistic token this time, and we're going to use the Y geometric mean for the cells in the monocytes gate. And you can see we've entered that value. And we'll do that again here for our 10 microliter sample. Statistic token, Y geometric mean for our monocytes gate. All right, so we have this table filled out now, and as you can see, it's as simple as just dragging and dropping from any of your data files. Since these are all tokens, as I update the gate, you can see that the values in that data table are updating in real time with response to these gating changes. Since we have the monocytes gate applied, we're going to see that change when we move the monocytes gate or the size gate. So let's flip back to one page now. We have this data table set up, so we can move it over here. And if we'd like to insert a scatter or regression plot for this particular data, all we need to do is select this plot or select this custom data table, choose scatter with regression, and insert a scatter with regression plot. And you can see here that we're plotting the concentration versus the CD64 MFI for this particular data set that we have set up in this plot. And the reason I have column C left in here is just to show you that you can pick and choose from any of the different parameters that you have in this custom data grid of yours. So if you were to choose column C, obviously there's no data there, but if you did have data in that column, you could very quickly and easily click to that column, and this is going to allow you to work with as many different parameters or kind of overlays for these scatter with regression plots. So you can see here that with this scatter regression plot, we have this kind of curve through the points here that's not being visualized very well by a linear fit. So let's do some formatting to this plot to make it look a little bit nicer. So I'm going to double click to access my formatting. And some of the things I want to do to this plot is probably I want to change the axes here because I want to not start at 161, which is the minimum MFI of my data set. Let's start at 0 and say expand this out to 1000. Click preview. You can see that now we're fitting, or we adjusted this axis to fit this a little bit better. And for our x-axis, let's actually just go from 0 to 10. And you can see we adjusted that to make this look a little bit nicer for the data. Now we want to come into our regression fit options now because we probably don't want to use a linear fit for this data. It's an antibody titration, and one of the fits that we have available is a Michaelis-Menten curve, which is specifically meant for working with antibody titrations. So I'm going to change this Michaelis-Menten curve, click preview, and you can see that our fit is fitting much nicer now. It's coming right through our data points. We have our Vmax value, which is essentially where this curve is maxing out. We have our goodness of fit and the Km value associated with this. So we really have everything that we need to start working with the scatter with regression plot, so we'll click OK. And again, you'll notice as I update any of these gates, as I mentioned, this regression is going to update, and if I undo, we can get back to where I started. So there's some other information that we want to get associated with this particular experiment. One is, let's actually put in a text box here, and let's start getting some of the fit parameters associated with this experiment. So as I mentioned before, we can drag this whole plot in there, choose a statistic token, we will choose the regression parameter statistics, and let's start with the model name. Right? So we put in the model name here. We'll type in model name, and we know it's Michaelis-Menten. If we were to change to, say, a linear fit, this model name would update for us in real time. We also want the Vmax. Oops, let's enter there and say Vmax. And we also want the R² value for this particular data set. So let's go ahead and insert these. Again, what we can do is just drag this plot in here, choose a statistic token, regression statistics, choose our Vmax parameter. You can see there's our Vmax value. Another easy way to access these tokens is simply do a copy and paste of that Vmax token, and then we can double click on the token and just come in here and change that to an R² value. So you can see here we can quickly and easily display all these data values, all these statistic values associated with this plot. Now for this data set, we also want to create some custom values because we know where the Vmax is for this particular data set. But when you're working with antibody titrations and you're working with titrating out antibodies, you don't necessarily need to use the maximum value in this curve. If you want to save yourself some antibody, you may want to use what is giving you 90% of your maximum binding. So that's a calculation we can actually do here in FCS Express using something that we call custom tokens. And custom tokens are available here in our View tab in the Tokens and Custom Tokens section. And you can see here I actually set up a folder for our custom tokens to create some new tokens, and I'm going to show you how that's done. And if you need some more information about what tokens are and creating them in FCS Express, please see our website, again, fcsexpress.com, and you can look in the recorded webinars section to find our detailed webinar on working with tokens and custom tokens. But what I want to show you is that if we wanted to create a new token for 90% of the Vmax, we simply create this token, and that token value is going to be the Vmax times 0.9. And in Excel, you would probably type in equals 0.9, an asterisk for a multiplication symbol, and then you would enter this value. In Excel, you'd probably just say 900.52. And I'm going to show you here when we enter 90% of Vmax, what this equals. Again, this is working with a static value, which works, but it's not nice, right? Because as we move this gate around, that static value won't change for us. We have to come back and manually change it. So instead of using the static value of typing that in, we could actually just grab this Vmax value. We will highlight it, drag it into our custom token view here, and you notice that it now says 0.9 times Vm, and that Vm is actually the Vmax that we've associated here. And you can see that our 90% of Vmax token is now going to update depending on where your gates are, and it's going to update on that dynamically updating token value for the Vmax. So it's in this way that we've created this new custom token to automatically calculate where 90% of the Vmax is for this curve, which is essentially telling us where 90% of our antibody binding is coming from. Now, if you wanted to take this a step further, which you probably would, what you want to do is figure out when you have 90% of your maximum binding of your antibody, as according to the CD64 mean fluorescent intensity, you probably want to know how much antibody you had to add at that point. And this is a calculation that most people do in Excel or some sort of graphing program, or they do it manually, where they take the model parameters associated with the fit and they use that to derive an X value from a Y value, or they use that to derive a Y value from an X value. So we have all that information already. We have the model fit parameters, we have the Vmax, the R squared, and the Km values. We also have our Y value here. We have our 90% of Vmax. And what we'd like to do is derive the X value to figure out how much antibody we would need to add to get 90% of our maximum binding. So you can see here I've set up a token just to explain how we're going to do this. We're going to convert our Y value to X at 90% of our Y value. And that token is going to equal essentially what we have is a formula. Just like you would access a formula in Excel, where it says we use a Michaelis-Menten fit to use Y to X, and then we type in 90% of our Vmax custom token and the model parameters. So let's actually show you how to do that rather than just typing that in here. Again, what we're going to need to do is put in an equal sign to let FCS Express know we want to evaluate something. And when you right-click here, you notice that we have the option to insert a function, and we have a category here for regressions. Now, we have a whole bunch of different functions associated with regressions. We have a full documentation of what these actually mean in our manual. But if I come down here to Michaelis-Menten, you notice that there's a Michaelis-Menten Y to X, and what this is asking us to do is when I click on it, It says use the Michaelis-Menten formula and convert a y value to an x value, and it's asking for what is that y value, and it's also asking for the model parameters. So we have this y value. All we're going to do is replace that text for y, we're going to delete it, with our y value from our analysis. And this is the custom token for 90% of the Vmax. Now, we also need to enter in the model parameters. And if we drag in this plot here, and we choose a statistic token, what you're going to find in the regression parameter statistics is that model parameters token. So we can just replace that static text with our token value here. All right, and we'll delete the static text sets here. And you notice that this actually appears in pink. What this means is it's using the text for the model parameters, but what we probably want to do is change this to a numeric format, since we're actually going to do a calculation. So what we have now is a function that's FCS Express is using to convert a y value to an x value. And again, just to reiterate, that y value is 90% of the Vmax, and the model parameters are the parameters associated with this Michaelis-Menten fit. So we're going to put this in a new line in our text box here. And you notice that it's giving us a value of 8.61, and that value of 8.61 again is indicative of when you have a 90% of your maximum binding in this assay, that's how much antibody is being used at that particular point. So we can say amount of antibody to use at 90% binding. And then we'll also come in here and put in microliters. So now we have this report that we've created. We have the model fit, we have our R-squared value, our 90% of Vmax, our 90% binding, and then we also know how much antibody to use at that particular time point. So again, what will happen here is if we update this gate, and you can see it, we're grabbing more or less data, we're grabbing different sizes of these cells that are our R-squared values, our max values, 90% of max, and our amount of antibody to use at 90% binding are all updating in real time. So again, this is going to make it very easy for you to come in and say, you know, if I need to change my size gate, if I need to change what I'm including as monocytes, and I want to get the best R-squared value based on my gating, I can come in here and update that in real time. And once you have created this layout, you can use this over and over again. You don't have to do this every single time. What we can do is actually just save this layout. And we'll do a save as. And I'm going to label this today's analysis. All right. And I will close this layout and we'll open it up again. So we have this layout, today's analysis. You can see that when we open this up, we've saved the gating positions, we've saved our scatter regression, our data, custom data grid here, and all the calculations that we've done. And if we ran another scatter regression, or if we ran another, a titration analysis with a 7-point series, instead of having to recreate this all again, you could just load in your new data to the data list, just like you would do with a regular layout in FCS Express. You would change the data files on these particular plots, or you would use a panel to do that automatically. And when you change that data and you update everything, your regression analysis is going to update, and you're going to immediately have the statistics that you need to determine where your 90% binding point is, as well as how much antibody to use in that particular titration series. So this is really simplifying what you need to do to get regression model statistics instead of having to export data to Excel, copy and paste, and manually enter in values for concentrations and model parameters and things like that. It's all going to happen automatically and in real time in FCS Express 5. So again, very quick and easy. Now, if you wanted to take this a step further and you wanted to export some of this information for your lab notebook, we could always use our batch actions to do this. I'm going to show you two actions to create here that might be useful. One is if you want to export this data to PowerPoint, we can create a PowerPoint presentation for this, and I will put it on my desktop. Okay. So here's our PowerPoint called test, and we'll click OK. We'll put these all in the same PowerPoint presentation. Oops. Let's make sure we put this in the right location. All right, and here's where we're going to save our PowerPoint. Now, what if we wanted to export to Excel as well? Maybe you have a running lab notebook in Excel for any of your titration data, sizing data, whatever it is. Well, we can click on Export to Excel. We're going to be prompted to create an Excel spreadsheet. So we'll call this test. And then we need to add information to that spreadsheet. And since we're just working with one titration series, there's a new feature in FCS Express 5 to report every iteration in a separate column rather than using a separate row. So if you're familiar with the batch processing in FCS Express, you may remember in version 4 that we could only go out to one row at a time for data. But for this data, it's going to make sense to use a column. And what I'd like to do is grab all of the information that's in here. I want to put in my model name. I want to put in the 90% our Vmax token. I want to put in the R squared. I want to put in our Vmax token. So you can see here all I'm doing is just dragging and dropping these token values. And the other thing I probably want to do here is put in the file name. So I'll drag this whole plot in there, and we will use the file name token for that. And I'll put the file name up here in the beginning as well. So again, what we've done here is just set up an export to Excel, and we're going to run this batch process. And what's going to happen on my other screen, or actually here it comes, we've exported to PowerPoint. So here's our analysis in PowerPoint. We have our titration plots on one page. We have our regression analysis on the first page. Again, these are all super high resolution documents that you can use for publication, or you can stick in your lab notebook or your electronic notebook. Now, the other thing that we have here is the information exported to Excel. You can see here that we have our file name, our model name, our VM, our R squared, and the custom tokens that we choose to export. So again, this is very quick and very easy to export all of this data anywhere that you need. And if you had multiple data files or titration series associated with this, you could add them all into the data list and then quickly and easily batch process over all of these data files. So again, this can be done with any type of data. We can draw upon any sort of statistics and tokens from the data using custom tokens. And there's a variety of uses for things like this, including sizing, calibration, titration curves, really you name it, anything that you're doing in Excel or Prism or GraphPad. These are things that we can do directly in the software. So the last item I wanted to show you today is quickly working with plate-based data. One of the things that a lot of people who are working with high-content imaging or flow cytometry-based data is they're generating IC-EC50 curves for their data, and they want to be able to get those inflection points on the curves. And what I wanted to show you is we actually have a plate-based data set. This is an imaging data set that we've loaded into FCS Express Plus. And the way that this data set is working is we have a titration series for a nuclear translocation assay where we're looking at the effect of two different drugs, highlighted in blue and highlighted in yellow. They're done in quadruplicates in rows and columns here. And in our heat map here, we've actually created a series of column gates. You can notice here that this gate is encompassing these four wells in our analysis, and that's the 0.31 micromolar drug addition of LY294.002. So we're actually pulling all of this data into one gate. Now we've set up those gates for all of the different wells and replicates in this particular plate. we've plotted the parameters of integrated intensity of the cytoplasm versus integrated intensity of the edge of the cytoplasm. And what this is telling us is as cells are translocating, the population is going from this heterogeneous kind of spread here between integrated intensity of the cytoplasm to just focusing and moving on from the edge of the cytoplasm to just focusing to this little population here. You can see over time or over the concentration series here that we're having more and more cells appearing in this translocated cells gate. And for each of these plots, you can see here in our current gate, we have one of those column gates from our heat map applied. So again, this is pulling all of the replicates into these plots. Now on our final page, we have an IC-EC50 analysis. We're going to set that up for you today. And what we've done is created a data grid just like I showed you with the Michaelis-Menten data. And each one of these points on the plot represents the data from the percentage of cells in these translocated cells gate as opposed to the concentration of the drug that we added. So what will happen here, if I move this main gate here, you can see that all of our dots are updating for us in real time. All right. So all we want to do with this plot to generate IC50, EC50 curves is double click on this. We're going to come into our regression fits. We're going to add a 4PL fit. And then we're also going to add a 5PL fit. Maybe we want to look at both of those together. And you can see that our 5PL and our 4PL fits are working very similarly. And if we want to generate any of that IC-EC50 values, again, all we do is insert a text box. You can drag this plot in there. From our statistics tokens, we're going to choose a regression parameter statistics. We'll put in the IC50 from our 4PL fit. And again, if we wanted to compare our 4PL to our 5PL, we'll just double click on this token value and we'll change it to the 5PL for the IC50. Click OK. And this is the differences between these. So this is going to be our IC50 for 4PL. And this is going to be our IC50 5PL. Right. So it's in this way we can compare the two different fits that we have for these data sets. And again, as we update this gate, we can see how those values change. Now again, the nice kind of thing about working with these plots, if we have any outliers in our data sets here, maybe we want to review what's going on here. Let's take a look at our single well gate. You can notice that it's on this black well here. And when we update the single well gate, we're updating what cells we're looking at in our image. And we can see that there's some changes here that, we're only locating one cell in that particular well, one cell in that particular well, and a few in these wells. So there's some variation here. These wells are highlighted in green, and these wells are highlighted in black, and we can see there's some changes going on in the images. So what we may want to do for column 9 is actually edit this gate, and instead of selecting all these cells, we want to select one or the other. And we can see in real time what is going to happen to our IC-EC50 curves and the plot as we adjust or add or remove particular replicates in real time. And if we wanted to completely remove the cells from that gate, we can see how that affects our curve, and obviously that's not a good decision. But again, what these scatter with regression plots are going to do for you is allow you to visualize the changes to the curve and the model as your gates and your data change. So if you're reviewing a data set and you find that there are no cells in this particular well, if there's some sort of specific reason that you want to exclude a particular well of your analysis, you can quickly and easily do that and have all these values change in real time. So if your R-squared values are going way off because of a particular well, you're going to know that, and you're going to see what a change to that gating position is going to do for you in real time. So that takes us to the end of the webinar today. We have, again, gone over a lot of different points here, And to summarize what we've seen is that in FCS Express 5, regression analysis and modeling can be created at a click. All you have to do is go to the Insert tab and insert a scattered regression plot for any of your FCS files, CSV files, any of your imaging data, or any of the custom data that you've put together within the software. These scattered regression plots, again, are going to work directly with FCS files or those custom data tables. The regression models are going to update for you in real time in response to any changes of your gates or data. So you get a real-time feedback on what your changes are doing to your data sets. Multiple models may be displayed and analyzed on the plot at the same time, so you can compare your 4 to 5 PL fits, linear fits, whatever you want to compare your statistics to side by side. Your model statistics can be used anywhere in the layout and used within custom tokens to create other customized statistics. So you could really have the flexibility to create any sort of report that you'd like and any sort of statistic based on your model that you would like. And finally, the analysis can be quickly and easily exported to PowerPoint, Excel, PDF, just like you saw us doing in the batch processing, or even if you wanted to just do copy and pasting, you can do that. So this is going to make getting to your results even quicker and easier than they were in the past. So if you have any questions about anything that you've seen today in the webinar or in the recording, please contact us at support@denovosoftware.com with any additional questions that you may have. Our team of flow and image cytometry experts is there, and we can answer your questions as they come in. You can also visit us at fcsexpress.com. You can get a free 30-day trial of FCS Express, and again, also to view a recording of this webinar at our website. I will show you the Novo software website here. Again, if you visit our website and you'd like to download a free demo, come into this Download tab and click on the FCS Express demo. You'll be prompted to get your free 30-day demo, which is going to include all of the scattered regressions, high content analysis, anything that you might want to do. And I also suggest having a look at our upcoming webinars. So if you'd like to register for another webinar similar to this, you can see what's available to you. And again, all of our webinars are recorded. You can come to our recorded webinars page and find any of the webinars that I had alluded to in this one, including the batch processing webinar and the custom tokens webinar that were given recently. So thanks again for joining us on the webinar today. We hope you enjoyed what you've seen and that you'd be able to put some of what you've seen into practice with your own data. And again, if you have any questions, please contact us at support@denovosoftware.com. Thank you and have a great day.